All right, recording resumed. Here we are. Here's your guys' lab page. Okay, so here, if you follow this poster, which is on my wall, help you out a bit. Right? So idea is I'm going to strike this tuning fork above this pipe with water. I'm going to raise it. It's going to resonate here, and it's going to resonate here. You'll hear it. We're going to take the difference between those two to that length minus that length. It's going to give us this distance here to here, which represents half of a wavelength. Double that, you get the full wavelength, and then right? Remind you guys that sound is a compression wave, longitudinal. So you guys see all these dots? Right? Represent like high pressure, low pressure, high pressure, low pressure, right? That's what's actually going on. Right? Now it's really hard to draw that accurately and see your diagram, interpret that. So it's really common to just whip off a transverse wave, which is a lot easier to draw, even though the sound is not really transverse, right? So there's just representational of longitudinal wave. Right? So here, let me flip my camera. Okay, yes. Put this whole setup in frame. Let's see. There it is. Got the set. Okay, this camera balanced. Fine. Right. I think that'll work right there. Okay. And let's try this out. And so the frequency on the tuning fork is 512 hertz. 512 hertz. Right. So that's the first box, 512 hertz. So that's known. Okay. Now listen, see if you can hear it resonate. You guys can hear that? Right. No, I don't know if the camera picks that up, but you can hear it in class. And then right there, right, that's where it's really loud. It's like resonating. Right? Let's see, what's the difference to the water line? Remember, the water line is where it closes off. So I'm looking at 16 centimeters. 16 centimeters. Right. So on this lab page, for the frequency, I'll call that 512 hertz. And for the length one, I'll call it 0.16 meters. Right, so you guys got that? 512 hertz and 0.16 meters so far? Okay. Now, what's the second place it'll resonate? I'm going to guess it's probably approximately 3 times that, which would be, what, 48 centimeters? Right. Now, probably won't be exactly that, but that's where I can start hunting around for the next place it'll resonate. See that? You guys hear that? Yeah, I think I found it. Right there, right there. That's it. Right, that is, right. Ooh, 53 centimeters, about 53 centimeters. All right, yeah, so a bit above. Right. I was saying, start looking around 48 centimeter mark. It's like 53 centimeters. So type in 0.53 meters right there. Okay. Let's just camera back over here. All right. That. All right. So now if I take the difference between those two, it tells you step by step exactly what to do. Okay. So take that difference. So what's 53 centimeters minus 16 centimeters? Right. So this is 37 centimeters or 0.37 meters. Right. Then if you want the wavelength, you'd have to double that, right? Because this represents half of a wavelength. So I'll just say times 2. Okay. So like at 0.74 meters would be the wavelength of, if I strike this tuning fork, here's what this means. You guys hear that note? Right? If you could see the compression waves in the air, right? It represent a wavelength of 0.74 meters. And then finally, speed equals wavelength times frequency. Speed equals wavelength times frequency. Okay. So wavelength is 0.74 meters. Frequency is 512 hertz. Right? Moment of truth. Guys, before I hit enter, what number are we ideally looking for here about? Yeah, about 340 meters per second. The closer that is, the better. All right, let's see. Ooh, 379. 379 meters per second. All right, so it's reading a little bit fast, but that's pretty close. That's in the ballpark. All right, you guys good there? But you guys see back in the lab area, a bunch of yeah, you guys see all the lab equipment you need. I'll walk around, help you guys out. Pick a couple of tuning forks. Try this out. Turn this lab page into the gray tray by the end of class, and I will give you guys points. Points.